Hello everyone, this is Gunashri studying in Sri Venkateshwara College of Engineering. Today I'll be taking up the topic additive group of integers modulo n respected to the subject discrete mathematical structures. So what is additive group of integers? So here in modular arithmetic, it is a fundamental concept in mathematics where the numbers will be represented in terms of their remainder when divided by a fixed integer that is known as the modulus. So here the additive group of integers modulo n, it is a powerful algebraic structure that will play a crucial role in various areas of mathematics and computer science. Along with this, not only so if a given positive integer, moving on to what is there next, basically moving to the definition. So here, the additive group of integers modulo n denoted as z is z plus comma plus is a set of all equivalence classes of integers under the equivalence relation of congruence modulo n. So here, which is expressed as when the reminders of the integers, which will be divided by n number. So in other words, when we take z by zn, which will be equal to a set of numbers that will be constituting. So how it will be defined? So the elements which will be taken as the elements of this groups are the integers zero, starting from zero or starting from one based on the requirement. So up to the numbers n minus one. So where each integer will be represented by its remainder when divided by n. So the operation that will be performed is addition when the sum of two numbers is calculated by adding the corresponding integers and taking remainder when it will be divided by n. So moving on to the properties of additive group, the properties of the additive group. The first one is the closure property. So here it states that the additive group of integers modulo n will be closed under the operation of addition. So which means that the sum of any two elements in the group is also an element in the group. Next one is the associativity. So it is in this group, we say that addition and additive group of integers modulo n is associative, stating that the order of the addition will not affect the result. Moving on to existence of inverses. So in each and every element that is present in the additive group of the integers, modulo n will have an additive inverse. So which is the element that when added with the original element results in the identity element 0. So here the identity element will be 0. Not only these properties, there are other properties like existence of an identity element. So here we state that the identity element is 0, which will belong to the z, which will belong to the integers category z. Next is commutativity also will be proved. So we state that the group operation is commutative, meaning that it will belong, it is commutative for all, where AB belongs to Z and A plus B will be equal to B plus A. Not only these, there are other properties like the additive inverse, order, and abelian group that are present in the additive group of integers modulo n. Moving on to what is congruence and equivalence classes. So congruence classes, the first relation that is defined as the congruence relation. So here, considering two elements A and B, if they are said to be congruent modulo n, and when they have the same remainder when they are divided by n. Next is the equivalence classes. So here, the equivalence classes will come under the congruence classes or the congruence relation, stating that all the set of integers will with the same remainder will obtain the same remainder when they'll be divided by n. Next is the representation. So it will be represented by any one of its elements, which are the integers. Moving on to what are the additive inverses and identity elements. So additive inverse states that it is if in a group of elements, if you consider an element A, then the additive inverse of that element A will be minus A mod n. So which when added to A, the result obtained as an identity element that is 0. What is identity element is the identity element in additive group of integers modulo n is the equivalence class contained in the integer 0. So when adding anything to 0 to any element, it does not change the element or it does not change the value. That is basically identity element. Moving on to arithmetic operations that is performed in the additive group. First one is the addition. So addition follows the same rule as a regular integer addition, but the result will be reduced to modulo, and that is a reminder that will be obtained will be taken. Subtraction is also the same as adding the additive inverse of the subtrahend to the result. Negation is also one such thing. Where the negation of the element in the additive group of integers modulo n is the additive inverse of the same. So here, taking some examples. So where will these arithmetic operations come into handies to make the additive group of integers useful is in the number theory and the cryptography field. Moving on to the applications of additive group of integers modulo n. So what are the different various applications wherever it is used as? First thing is the cryptography. So here it is the one of the fundamental concept in development of cryptographic algorithms such as the RSA and Diffie-Hellman key exchange methods. Not only this, but also in data transmission also. Second thing is the error correction codes. So here it is used in the construction of error correction codes, which are crucial for reliable data transmission and storage. Third thing in the field of science, computer science, where modular arithmetic is used in various areas of computer science, including hash functions, pseudo random number generation, and the finite field arithmetics. Not only these, but also used in the number theory, where it is used to study the properties of integers like primarity, divisibility, and congruences. Next, it is used in the field of algebra, where fundamental algebraic functions can be executed, and also it is used in network topology, where to study the connections and connectivity and the structure of network. Next thing, it is used in the coding theory. So coding theory basically to construct and analyze the error correcting codes. Next one is it is also used in number generation. So to generate random numbers in the sequence. So these was all the application about the additive group of integers. So moving on to conclusion. So it is one of the basic concept that is almost required that is required in mathematics, with having enormous applications in various fields. Next, we have to define about the algebraic structure. So here the properties like closure, associability, existence of an additive inverse, existing of an identity element, all these will play a very crucial role. Next is a practical significance. So here it has stretched its major process in like cryptography, error correction, and computer science, which is used in many different domains. Thank you.